and thank the conference organizer to invite me to be here. And I also want to say hello to Dr. Nim, and we have long not see each other before, but we have contact with for my review paper for many times. Can you change the slides? Yes, this is the formal one. Okay. Okay. Let me start my presentation. And I'm Zhou Li from Beijing Institute of Nanoenergy and Nanosystems. And I was a doctor, but I got a PhD in biomedical engineering. So now I'm an engineer. So my topic is about self-powered cardiovascular electrical devices. And first I want to talk about the electricity. The electrical activity is the fundamental and basis of human life activity. We can find the different level of the electrical activity in cellular level, organ level, and molecular level. The fundamental is the ion channels. So if we can regulating this kind of electrical activity in molecular cells and organs, we can change the state of excitation and inhibition, so that we can do the treatment or therapy for different diseases. There is several examples for the electrical stimulation as a therapy, but the history of the EST have been developed for a long time. We can see the bioelectricity from the electrical eels. We can get the discharge from the electrical eel and the electrical generator, then the frequency modulation electrical stimulation, then with the functional electrical stimulus. The first one is the implantable pacemaker. So we can see the developing history here. And this different equipment, including the electrical eels, to do the electrical stimulation therapy, can cure some of the diseases like the headache, like epilepsy, and to improving the circulation. And some of the electrical medical devices have been used for clinical for many in different patients. For example, the DBS, deep brain stimulators, and the cardiac pacemaker, PM, and the ES for heart diseases, nerve diseases, and including other systems like bone, skin, muscle, and other tissue and organs. So make the cardiac pacemaker as an example. We can see the development to see the pacemaker with lead and the leadless pacemaker from 2016. And these different pacemakers are using batteries to supply the electric power to give the electric stimulation. So there is an overview of the history of cardiac pacing. We can see from there, from this page, that the pacemaker was on the wheelchair, then a wearable, then implantable. From now to the future, it said in this paper, it said batteryless device which harvests cardiac motion will power the pacing circuit will become in the future. So there is a cell-powered technology in recent years that we can reclaim and harvest different kinds of biomechanical energy to transfer these kinds of energy to electricity. To do the in vivo and in vitro electrical generation, they use this electricity to do the EST, to do the electrical stimulation therapy. There is two different kinds of nano generator for this purpose. The first one is piezoelectric nano generator. It means we use piezoelectric material can reclaim, to harvest or transfer mechanical energy into electricity. Then the triple electric nanogenerator, it uses two kinds of effect. The first one is triple electric effect. The second one is electrical inducing effect. Combine these two different effects, we can get electrical energy transferred to, mechanical energy transferred to electrical energy, electricity. So in our lab, we are doing the devices to reclaim or harvest or transfer the mechanical energy into electricity from the mechanism to the design and modeling, then the material and device, to now we are doing some systematic applications in the clinical devices. So I want to introduce two different kinds of devices for the electrical stimulation. The first one is a cardiac pacemaker, and we using the cell power technology to powering the cardiac pacemaker, so we call it SymBiotech cardiac pacemaker. SymBiotech is coming from the batteries and plants, and this work is published in 2019, and this is the first demonstration for the 4 plantable devices which can be used heart beating to powering the pacemaker. Okay, the energy from each heart beating we can get is 0.495 microjoule. But the pacemaker, if the pacemaker to release a pacing electricity, just need the minimum is 0.375. So we get more energy from the heart beating, more than the energy consumption of the pacemaker. So we did this animal experiment to do in pig to prove that we can use this electricity we can reclaim the electricity from heart beating, and to correcting arrhythmia in large animal model. And we can see the videos here. And SPM can be controlled by wireless positive triggers, which was fabricated, and its ability to regulate heartbeat is demonstrated in these 2 videos. And the device is the human-used pacemaker, which have been taken out from the patient. The battery is died, but we use our device to generate enough power to powering the pacemaker. Okay, this work has been published here, and I want to thank Professor Nim again because Dr. Nim gave a research highlight to our work, to this SymBiotech cardiac pacemaker, and other researchers and doctors have gave our comments too. And the second and to the fourth work, I want to give a brief introduction. The first one is a self-powered lower-level vagus nerve stimulation system for atrial fibrillation treatment. And the second one, we also can use these kinds of devices for the cardiovascular disease detection, and from the HRV to analysis from the HRV, and the cell-powered transcatheter endocardial pressure sensor in heart atrium and ventricle. And the cell-powered this device is accurate and very stable in the chamber of the heart. And we also did some bioresorbable pressure sensors which can be delivered to the implant into the body, and to do the pressure detection of the blood vessels. And these are some videos about that. And then, yes, the last one, I want to talk more about the wireless needleless pacemakers. We have, using these kinds of devices, have integrated with the needleless pacemaker, which can be delivered by the transcatheter into the chamber, and to harvest the energy of heart beating to powering the needleless pacemaker, cooperated with the National Cardiovascular Disease Center. And last part, I want to introduce the publishing experience with Nature Review Cardiology. Because Dr. Nim gave us a highlight here in this highlight paper, and he asked me some questions about our work. Then I sent an email to him and asked if we can organize or publish a review paper for NRC. And then we published this paper, Cell-Powered Cardiovascular Electrical Devices and System. Because it's very engineering, so we have a lot of talk about the review during we prepare it. But Dr. Nim also gave us very good examples for how to write and organize the artwork of for the Nature Review Cardiology. And for the original figures is here, and the published paper is there. They also, the publishing group also gave us very good supporting to revise and redraw all of the figures in our review paper. We also changed our figures a lot. And then finally, we get our paper published in 2021. And this paper is also the high ESI high cited paper. Okay, this is my group, and I come from Beijing Institute of Nanoenergy and Nanosystems and the University of Chinese Academy of Science. And we have a big group and a small, and a platform for the MEMS and the fabrication equipment facilities, and also thanks to the fundings. Okay, thank you for your attention.